All right, Dixie, May the 5th. This is the last time that you will have this video from me. So I just want to speak, before I get into the lesson, I just want to tell you, just from my heart, how much I miss not having you in class. Even though I only had you guys for the first 2 weeks, it might have been my most enjoyable 2 weeks I've spent at Dixie in my entire 4 years there. And I truly, truly loved having you in class. Anyway, I'll address the last thing I want to say at the end of the video, but let's get into the content. Today we're getting into birth defects. And we're going to talk about chromosomes, recessive traits, dominant traits. All right, so what's a chromosome? Well, it's an allele that we get from each parent. All right, so I get one from my mom, I get one from my dad. That makes up a chromosome. Well, how many chromosomes do we have? We have 46. All right, so 23 different pairs for a total of 46. All right. So we get certain traits from our mom, we get certain traits from our dad. And what we get is depending on something called a dominant trait or a recessive trait. And so some of you have probably done Punnett squares before, so let's get right to it here. All right. If you see a capital letter, okay, that means it is dominant. And a dominant is always, 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 always going to override that recessive trait. Okay, that dominant trait is going to appear. The only way for a recessive trait to show up is if you have two recessive traits, all right? Because if you have one recessive and one dominant, the dominant's always going to override it. So you must have two recessives, all right? So if you ever see a capital letter, in this case, and we're going to do some Punnett squares, capital letter means dominant. A lowercase letter, is recessive. And if you see one of each, we're talking that as a carrier, all right? So put that up there. You can always go back to reference that. All right, so a dominant trait that most of us have. Well, most of us have a hitchhiker thumb, all right, where the tip of our thumb bends backwards. That's dominant. Some people are straight as a board, okay, and they cannot bend the tip back at all. That would be a recessive, but most of you can bend it back. That's a dominant. Your earlobes, most of them are called detached, all right? You got that little loop on your earlobe. Right. Again, dominant. Recessive would be where it's connected right to the almost to the jawline, right to the skin. Another common one would be a tongue roll. If you can roll your tongue like a taco, all right, that's a recessive trait. It curls up. All right. A recessive trait is they couldn't. It would be, and they can't curl it. All right. So let's understand this here. Do this super fast. All right. So here in this case, I put the father on top and the mother here on the side. It doesn't matter. You put them either way. It doesn't matter. And I put an R for the tongue roll. R for roll. All right. So dad, mom, that would be a capital R, capital R. All right. So that child right there, if they had an offspring, 25%, boom, immediately. All right. They are, that tongue will be able, that child will be able to roll their tongue. Same thing here. All right. Now we finally got a recessive trait here. But we still have the dominant trait. So the R, capital R there's a lowercase r, and we got another one right there. So you see a capital R in every single one. So in this case, that dominant trait is always going to override it. So 100% chance this kid is going to be able to roll their tongue. But what they do have is a 50% chance right here that they will be a carrier. They might pass this down to their offspring. All right, but 100% chance that this kid would be able to roll their tongue. All right, their grandkid might not be able to, but that kid would be. All right. Let's get a different scenario. Dad is a carrier, and mom, she can't roll her tongue. All right, she's got that recessive trait. She can't roll it. All right, so let's figure out this. What's their chances of their children being able? That'd be a capital R and a lowercase r and another lowercase. So here we go. Boom, right there. That kid will be able to roll their tongue. 50%. Dominant will override that recessive. But here you got a 50% chance that that kid will not be able to roll their tongue. All right? So this is a 50-50. But there's 100%, because you see the small r in every single one, 100% chance that they will be a carrier at least. They would be able to pass that down to their offspring, to their kids, next generation, right? But their kids, all their kids, 50% chance that they would be able to roll it, 50% they would not be able to. All right, last one. Dad is a carrier. Mom's a carrier. Big R, little r, big R, little r, and little r, little r. All right. So 75% says that they will be able to pass it down. All right. But you see the capital R. 75% says their their kid will be able to roll their tongue. All right. Only a 25% chance says they cannot. So this is a 75% chance that they could, or a 25% chance they could not. All right. But there are a 75% in terms of being a carrier, passing that down to their offspring. All right. So why does this all of this matter? All right. Quite frankly, rolling tongues is not important. What is important is some types of genetic birth defects, and let's talk about three of them. Two of them are going to be what we have to do with recessive. Okay, the other one's going to affect a chromosome. So let's talk about this one, cystic fibrosis. You might know somebody has cystic fibrosis. Somebody has cystic fibrosis. You can't look at somebody and say, "Oh, that person looks like they have cystic fibrosis." Right? It's not that at all. They oftentimes might be thin, but because of their metabolism, but you can't ever identify somebody that way. Cystic fibrosis is the #1 genetic birth defect. It affects the 7th chromosome. Okay, it creates this mucus that builds up in people's lungs. Oftentimes, you get the question, "Well, why can't you just get a lung transplant?" Well, you can, but it's not a problem with the lung; it's a problem with their DNA. Right? They're always going to secrete this mucus, and whether they have a new lung or an old lung, that lung is going to now also secrete extra mucus that is going to make this very difficult for a person to breathe. Not only will it affect the lungs, but eventually over time affect somebody's pancreas and liver. All right, that's kind of faded. 1 out of every 20 Caucasians or whites are carriers, and you're going to find this in a couple things here that we're writing. Why certain birth defects or certain types of diseases affect some others. Well, even though America is becoming well more diverse, and it's a wonderful thing to see, we still have to remember this: whites still typically procreate. Okay, they typically marry and still have children with other whites. Blacks still typically, statistically speaking, will marry other blacks. So even though we're becoming more diverse in our culture, we still see certain types of diseases, certain types of birth defects that are still in certain types of races. So 1 out of every 20 Caucasians would be a carrier. And this is a progressive disease. So this is going to make somebody lung deteriorate over time. It's going to get worse and worse. Now, you can get lung transplants, but lung transplants only work about 50% of the time, and if you would get a lung transplant, it's kind of a short-term thing. It might extend somebody's life about 5 years, okay? Their life expectancy, again, is at the age of 30. Now, we've made a lot of strides that way. It used to be all the way back in the teens. We've now upped that rate up due to certain types of medical treatments, okay? Anyway, what's bad about this is there's no funding. Our government doesn't provide any money for this type of genetic birth defect, and it's the #1. All right, so hopefully that'll get fixed sometime soon, so we perhaps can at least have better treatments, if not even a cure. Next one, sickle cell anemia. All right, as the other one affects mainly Caucasians or whites, this one mainly affects African Americans or people that live around the Mediterranean Sea. So 1 out of every 13 are a carrier. Cystic fibrosis, 1 out of every 20 are carriers. Didn't say that they haven't. They're carriers. All right. So when we have to go back to carriers here, all right, we can identify what would be the likelihood. Now, you can always get genetically tested. You can go to the doctor and say, "Hey, am I a carrier for sickle cell or am I a carrier for cystic fibrosis?" You could do that, and certainly do it right before you get married if you were concerned about the person that you were marrying and then having children with them. I'm not saying you shouldn't, but that would be an option. All right. So what happens with sickle cell? Well, when somebody has sickle cell, just like the name, sickle, all right? It's a crescent shape, all right? Kind of look like, normal red blood cells would be a round circle like this. But when they have low amounts of oxygen, that shape turns into like a crescent shape or like a moon. Well, the problem with that is when it tries to go through our blood vessels are circular. circular. So when you have a shape like a banana or a moon going through there, it has a tendency to clot a lot more. So you have a lot more chance of heart attacks and strokes. Well, what is that going to do? That's going to affect somebody's life expectancy. So oftentimes somebody lives somewhere between the age of 40 and 60 with sickle cell, and you have to also worry about where they live and how they're exercising. So if you go to some city like Denver, mile high, low oxygen levels, that could be a serious problem for somebody. Okay, so kind of keep that one in mind. Next one, Down syndrome. This one affects the 21st chromosome, but it's not necessarily a genetic birth defect like the other ones. The number one factor on this one is the mother's age. So instead of having a normal 46 chromosomes, you have an extra one. It's an extra one on the 21st chromosome, so you have a total of 47. And I'm sure you've seen people with Down syndrome. Some common appearances might be slurred speech, a little bit overweight, shorter in stature, poor muscle tone, and due to those types of complications with the excess fat, oftentimes there's obesity, and that can have a negative effect on their kidneys, their livers, their heart, and that can reduce their life expectancy as well with Down syndrome. All right, so go back to this mother's age. Oftentimes you hear a woman who's high risk after the age of 35 if she's having kids. Well, this is one of many of the factors why she might be high risk. So if a girl, let's say for argument's sake, here's some stats for you. If a girl was at the age of 24 when she had a child, she'd have about 1 out of every 2,000 births at the age of 24 of having a Down syndrome child. Not very likely. But if you get in your 40s, let's say just flip those numbers from 24 to 42, right? Now you're talking about 1 out of every 63. So you can see the huge difference between 1 out of every 2,000 and 1 out of every 63 births. All right, let's do one more. This has nothing to do with the genetic birth defect, but this is probably one of my favorite ones to talk about, and it's talk about cerebral palsy. And cerebral palsy is when somebody has a low amount of oxygen at birth, right before birth, at birth, at time of delivery, or immediately after birth. We talked about yesterday how a doctor and a nurse will run over, take the baby, suction out all that mucus out of the baby after it gets delivered. Well, it needs oxygen. They don't want this to occur. Some of you might have ever heard about an umbilical cord being wrapped around somebody's neck at the time of birth, where it might cut off the oxygen to the brain. Another common occurrence of cerebral palsy. Also, high amounts of radiation you might see with cerebral palsy. You might find a nurse who normally takes x-rays, but if she's pregnant, she might get relocated somewhere in that doctor's office or doctor's building because they don't want it to be exposed, right? So if somebody had cerebral palsy, they might, what we refer to as hypertonic, and their muscles are very tight and rigid, okay? They might have an IQ that might be fantastic. All right, it might be much higher than yours and mine, but oftentimes they might not be able to speak. They might be wheelchair bound because they will not be able to control necessarily their limbs based on the part of the brain that was affected due to the lack of oxygen. All right, so I put in a couple of videos I'd love for you to go watch. One of my favorite articles to read to class is called Strongest Dad in the World, sorry. And it's about a guy named Rick and Dick Hoyt and their troubles and as they went through life and what they've actually been able to accomplish by it. It's a fantastic read with some amazing videos. But before I leave you today, and before I leave for the rest of the trimester, I just want to say this again. Thank you so much for being amazing students. I truly appreciate our time. Since we've been in NTI, for a little over 5 weeks, we've had, 6 weeks, but 5 weeks ago we had our first death in the state of Kentucky due to COVID-19. All right. As of this day, as I'm filming, we are excess of 225 deaths. All right. So we have increased over 225 deaths in 5 weeks. We went from just having a few cases right before we left to now having over 4,500. All right. Guys, I have no idea where we're going to be. That was in 5 weeks. I have no idea where we're going to be in 5 weeks from now. I have no idea what we're going to do in terms of starting school next year. Please be safe, be careful. The one thing I think you understand that I am not, I don't ever lie to you guys. I never tell you anything false or anything. This is something very serious. Please take care of your family. Please take care of yourself. I hope that we're back at school at the beginning of the fall. There's a good chance that we are not, whether we're coming back after fall break or Christmas break. I don't think anybody knows to this point. Be ready for anything. And when you are back in school, please come back. Welcome me. I hope to see you guys. I hope that none of your family is stricken by this horrible, horrible virus. Good Lord willing, that we'll all see each other and we'll all be back sometime at Dixie starting next year. I miss you guys. Love you guys dearly. And I hope you guys have a fantastic summer. All right. Bye-bye.